Good morning. So welcome back to the session on design and analysis of algorithms. In the previous session, we were talking about quicksort. Okay, previous 2-3 sessions to be precise. We were talking about quicksort, and yesterday's class we sort of stopped right in a place where we were talking about the worst case scenario with regard to quicksort. Now, what is the worst case scenario and what needs to be done? Now, what is the thing to be kept in mind? When do you think the worst case scenario will happen? When the already the array is in ascending or descending order, then the worst case scenario will happen. For this, we even saw the tracing policy of it. Now, what is the tracing policy we saw? Okay, we took this example where you had something like a 22, 33, 44, 55, which is already a sorted array. As you can very clearly see, it's very much a sorted array. But we did everything that is related to quicksort. We did all the steps of comparing the key value with ij, everything. At the end, what we did? You know very clearly that the first element will be your key element by default. Okay, which was with regard to 22. At the end of all the steps, once we applied all the steps, this is what we got. Okay, this is what we got. At the end of it, the array was still like this itself. We had 22, we had 33, 44, and 55. Of course, this being the very fact that it is already a sorted array, this is what we got. The key element was still 22 and was still right at the first place. It didn't move to the middle part. Okay, but we did so many iterations. So many iterations, no change in array. You call it as a worst case. Okay, you call it as a worst case. And what is the thing that we always know with regard to quicksort? That the mid element, okay, the mid element is nothing but the key element, which you can clearly see right here. This is not the key element, and towards the this side you need to have left side, towards the this side you need to have right side elements. Left side should be elements which are less, right side elements should be some things which are more. So element here, okay, all the elements towards the left side of the key element. You can see the key element right here, and all the elements that are towards the left side of
ಈಗ
the
ತಾನೇ
key.
ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ದಮ್ಮ
Okay.
ನಡೆ
What needs to be done with regard to that? First and foremost thing is there are no elements. Be careful here. There are no elements towards the left side of the key element. There are no elements. Understand here. There are no elements with regard to the left side of it, but towards the right side of it, there are three elements. Okay, there are three elements. So I want to put this in form of a general case or in a general term. What I can do, I can write this entire thing in a way like this. What is the number of terms? The number of terms we took, which is nothing but n, is equal to 4. And towards the left side of the key element, we have 0 elements. Towards the right side of the key element, we have 3 elements. Can I write the 3 elements in general as n minus 1? Yes, I can write that. Okay, I can clearly write that it is equal to 4, and the right side elements is with equal to 3, which is nothing but n minus 1. Okay, this is the worst case scenario. Okay, where do you think the worst case will happen? People will ask. Okay, generally this is more like a technical round question when you happen something in gates, something in technical rounds of your placements, such things. This is where it happens. Okay, these are things that you got to be knowing when it is already sorted. Okay, when it is fully sorted, then this is what you call it as worst case. Okay, this is what you call it as worst case. That's the most important part you need to keep in mind. Now for this, we're not going to end it here, right? We are going to figure out what is the time complexity of it. Now be careful, we have already found out the time complexity for the best case. Okay, and of course the average case also is same. Best case and average case, you got some value, but here the value will change. For the worst case, of course it will not be the same, right? Same complexity will not come. For the worst case, of complexity will increase. Okay, so we are going to find the time complexity for it, how it has to be. Okay, that all these things I'm going to put it in form of an equation. In form of an equation, what will be the equation? The equation basically comes like through like this. Okay, now you can clearly understand what is the meaning of trying to talk here. First and foremost thing, okay, the one what you see towards on the right side of it, okay, where if the n number of elements is only 1, I rate is equal to 0, because of course there is only one element. Okay, then there are a few things that you got to think of or you have to understand towards the the below part, this one. Now what is T of 0? T of 0 represents that there are no elements towards the left side of it. Okay, no elements towards the left side of it, and it can be easily equated to 0. And then you can maybe thinking of what is this? There are n minus 1 elements. That's what I was talking, right? There are total what? N minus 1 elements towards the right side of it. That is what I have taken the time complexity of n minus 1 elements. And what is this? It's not just n, it's Cn. Okay. And what do you call this? This is nothing but the time complexity or the time that is needed to do what? To do what is known as the combination of it. Time required to partition the array into two arrays. Okay, so can write that entire thing like this. Time required to do what? Partition. You need to sort of partition the entire array into two parts, right? Every time. Okay, required for partition. So you got all these things with regard to best case. Be careful of what I took in the previous average or the best case and what I'm taking with regard to the the worst case scenario. This is something which you need to keep in mind. Okay, so this is the first thing we got. Based on this, obviously we are going to figure out what is the time complexity. Okay, how it can be done. Now you can see very clearly the first one I'm not going to take, n is equal to 1, it is 0. Everyone, you can't get anywhere from there. Okay, obviously I need to take the second equation. So if I take the second equation, so I'll take the second equation. So let's sort of look into this, figure out what is it. T of n, the time complexity of the worst case scenario, is given by T of 0 plus T of n minus 1 plus Cn. Okay, Cn. This is what we got with regard to the equation. Now, if I keep on doing what is known as substitution method, I'm going to apply what is known as a substitution method. Okay, so basically what is the meaning of substitution method? One after other, you're going to apply the substitute values of it. So I'm going to apply substitution method. So let's check, what is going to happen with regard to this. Okay, second, yeah, I think now it's clearly visible. If you can't see, please zoom in. Okay, every time you zoom, because screen control, if I keep on doing that, the class will not move forward. Okay, so if you can't see, please zoom in. Right, what's the next thing? Okay, see, this is what the equation is. Now what is the way of writing this? Okay, can I write this entire thing as equal to what is T of 0? T of 0 is on top of it. You can see very clearly towards the, or else you can see right here. What is if I put T of 0? If I put n is equal to 0, okay, n is equal to 0. T of 0 will be obviously equal to 0. Okay, T of 0 will be equal to 0. So that will not be very much for it. So this will happen equal to what? T of n minus 1 plus Cn. Okay, being the fact that you have T of 0 equal to 0. Okay, what's the next thing? Next thing is, see, this is for the T of n. What is for the next term? What will happen to the next term? Next subsequent terms, what is going to happen? Okay, if you got T of n minus 1 plus Cn, for the next term, what is going to happen? This will be happening like this. Okay, T of n minus 1 for the first term. If you think like that, okay, for the first term. So the second term would be T of n minus 2 plus, be careful here, this I'm talking about with regard to n minus 1. So this will become C of n minus 1. I'm talking about the next subsequent terms, or else in simple words you can say replacing what? N by n minus 1 in the above equation. Like that also you can say. Okay, C of n minus 1 plus Cn. What do you call this? This is the next term, next subsequent terms. Okay, T of n minus 1 plus C. See, I'm adding C, n minus 1 is there. Next term is becoming n minus 2. Here n is there. So next term should be n minus 1. So next term should be n minus 2. Next term should be n minus 3 like that. Okay, the Cn will remain constant right here. Then for the next term. Okay, then for the next term, what is going to happen here? This will become T of n minus 3 plus C of n minus 2 plus C of n minus 1 plus Cn. Okay. In very simple terms, you can say, or else you can say, okay, replacing n minus 1 by en minus 2 like that. This also you can say, or else you can just say next subsequent terms would be basically like this. Okay. So what is the way of doing this? So like this, if you keep on moving ahead. Okay. So I'll say, always say this, right? So if you keep on moving towards the next thing like this, what you're supposed to get? Okay. What you're supposed to get, you are going to get a value which is almost similar to this. What is that? Be careful with the way I'm writing is T, N. See this? I'm going to represent all these terms. Okay. You see the values of, or else you can say like this. Replace 3 by N, or else in other way you can say writing general form. Writing the general form of this equation, what is going to happen? T n minus 3 is there, right? So obviously that will become n minus n only, plus C of, be careful here, n is there, you will write n, and be careful with it is, see, I'm taking 3 as n. Okay, I'm taking 3 as n. So what will be 2? 2 will be n minus 1. Okay, n minus 1 plus C of, again, n minus n minus 1 plus like that. Okay. So or else in very simple terms, okay, if you get this confused, in very simple terms, I can write like this. Of course, if you sort of do that step also, you are going to get the same thing itself. Or else in very simple step, this will happen like this. T of n minus n plus C of 1 plus C of 2. If you put that value of the 3 by n, you will also get the same thing. Okay, plus like this, it will keep on going till you have your C n minus 2. Okay, C n minus 1, then up to your C n. Okay, this is what you're supposed to get. And what do you call this? This will become T of 0. Okay, T of 0. You know what is T of 0? Okay, then plus C of 1 plus C of 2 keeps on going up to C of n minus 2 plus C of n minus 1 plus Cn. Okay, or else I can write this entire thing. This will become, entire thing is 0, right? So this will become, this thing will become 0. Okay, plus now this you need to understand. This you can see very clearly. It is 1 plus 2. Of course, if there is one more term, it will be 3, 4, 5. Then it will become n minus 2, n minus 1 up to n. Up to n. See, it's starting from 1 and it is going up to n. So what is the way of saying this? Can I say this entire thing is nothing but sum of n terms? Okay, this is nothing but right from here to here is nothing but sum of n terms. You can see very clearly, starting from 1, 2, 3, 4, 5, 6 like that up to n. So this is nothing but sum of n terms. Of course, only when you take 1, 2, 3, 4, but C remains. C is there, right? C is there. So you can write this as C of sum of n terms. Okay, sum of n terms. So can write this next step. The next step becomes very important. See, these few instances only you need to sort of use your head. All other places there's no need to worry about. Okay, once you get these small instances correctly, then later this becomes everything pretty easy. Can write this entire thing as just C, and be careful here why I'm writing this sum of n terms. What is the sum formula for sum of n terms? Can write this as n into n plus 1 divided by 2. What is this? This is nothing but a formula to figure out the sum of n terms. Okay, the sum of n terms. So I can clearly write like that. Okay, now what is the way of doing this? What is the way of thinking about this? Okay, this T of n, the time complexity of n is C of n into n plus 1 divided by 2 is what we got. Okay, is what we generally got. Okay, this we need to figure out what is the value that you are going to get. Okay, what is the value that you are going to get, and you can see very clearly this is with regard to this. You can write it as n square plus n. Okay, 1 by 2. This is with regard to n square plus n. Okay, 1 by 2. This also you can write. Okay. Now, what is the way of we are talking about this? I'll give an example. If n value is equal to what? 100 or 10. Keep this as 10. What is this value based on? This will happen. You got your 100 plus 10 divided by 1 by 2. Okay. This will happen as what? You have here 1 by 2 of 110. So this will become equal to almost 55, right? It is nothing but equal to 55 because with the sum of n terms, this is what we are going to get. Okay, this is what we are going to get. So predominantly you can see what is the bigger value here. The predominant bigger value is with regard to n square. Okay, the predominant bigger value is with regard to n square. And what is the other reason why we need to put it in form of an n square and all? Because all your time complexities should be in terms of n log 2n, n log 2n, n square, n cube. All your time complexities should be somewhat represented using all these things. Whatever time complexities we have seen till now will all be equal to either one of this. That's you called as orders of growth. Okay, you call it as orders of growth, and this is where it is basically. So this entire formulation of whatever you got, it is almost, okay, be careful here, I'm not writing equal to, I'm writing it is almost equal to a n square. Why? Because n square is a bigger value here. Okay, n square is a bigger value here. So your time complexity with regard to quick sort, okay, quick sort of t of n is n square. What n square? Okay, you need to know what is that n square. Big O of n square. Why? Because your O will be representing your worst case. Okay, worst case scenario. So big O of your n square. Okay, this is something that you've got to keep in mind. Okay, the time complexity of your quick sort. In exam, what is the way to do it? Okay, well, learn all these things, that's all fine, but at the end you must know where you're going through when it comes to exam. That's the most important part, right? So in exam they generally ask you quick sort, the tracing, everything, and they're just going to ask you what is known as the time complexity of it. Many times, majority of the times, they're not going to specify what time complexity. So what you have to do? You have to always by default go for the best case at the average case, best case and the average case. Okay, so quick sort, you can know very clearly what is the value for it. Then if they explicitly ask, the worst case, then only you have to go for this and then write that it is of what equal to n square. Okay, we go off this, otherwise this will be with regard to what? Theta of your n log n. What is the value we got with regard to the best case and all? Okay, in the previous thing we saw it. Okay, n log 2n, which is this one. Okay, this you can sort of do it because again we saw that was using Master's theorem. It was pretty easy. This is also pretty easy. If they ask explicitly, you can also go for it. See, our job is to be prepared for the worst. Okay, that you got to keep in mind. We should always prepare for the worst, and anything that comes, we should be able to do it. Okay, it's as simple as that. That is something that you need to keep in mind, that what is the way to tackle all these things. Okay, quicksort tracing becomes very important. Tracing in quicksort is the most important part. Then you saw with regard to algorithms. Don't forget algorithms. Okay, don't forget algorithm, and then of course the time complexity. So it comes like a package. Quicksort, you need to know all of this. Okay, you need to know all of these things. So and you have to keep this in. Okay, Probably once the internals everything gets over, okay, we are going to start with what is known as the lab programs. Again, I hope by this time you know Java programs. You know Java programs. You must be knowing Java programs. Okay, there's no one's gonna teach you again Java. You should have learned that way back in your OOC classes. Okay, and again that's why I'm saying fourth sem is tough, because this is the last semester where the toughness index will be like that. From fifth sem everything will become easy. A majority of the subjects are theory based. Even the lab subjects what you get are predominantly not that programming based. You get a lab like DBMS, where it is all about queries, and computer networks, which is all about figuring out. You would have seen DC, right? The same thing. There are more things with regard to that computer networks, which is all about finding out the latency, bandwidth, frequency, like that, using the programs. Okay, so not much there, not much of a programming right there. Okay, so this is something that you need to keep in mind. Okay, majority of the program here also. Here the programming is not your figuring out what is the program to be written under. It's all about figuring out, okay, what is the value I'm going to get. It's a mathematical representation using programs. That's all. In the lab I'm talking about. Okay, so majority of this is all this. So this is why I always say the combination. This subject is a combination of your both. All your programming skills, which is very very minimal here, but majority of it is analytical skills. Okay, analytical way of writing things become very important here. Okay, fine. So now we move into the next part of what we are going to study. Okay, so what are the things we studied till now? Okay, the things which we studied and everything related to it. Okay, so we saw with regard to the divide and conquer. So I always call it as DAC, divide and conquer, DAC technique, right? So under DAC technique, you saw the general algorithm, everything. What is the the abstract, the general algorithm for DAC also you saw. Okay, and then the most important part we started seeing was with regard to the examples. Under DAC, how many types of examples we need to study, because that's what it becomes very important. Okay, so the first one we basically saw was with regard to merge sort. Okay, something we studied, we already studied. The second one was with regard to binary search. Again, you would have studied that in second sem itself. Okay, the third one was with regard to quick sort, which is did each and everything related to quick sort. The next one is with regard to what? Strassen's matrix. There is this person called Strassen. Okay, and we are going to learn about his techniques with regard to matrix multiplication. All these things are examples of your what? Divide and conquer technique. People will ask you, under divide and conquer, what and all you studied? These are the things you need to study. Okay, merge sort, binary search, quick sort, and the Strassen's matrix multiplication you're going to study now. Again, here the same old thing will come, but one advantage here is there's not much to be read except for very very few things here. Tracing is not much of a problem. Okay, because it's matrix multiplication, right? Everyone knows matrix multiplication. Of course, there's one thing to be kept in mind: the formula. The formula will come through here, where you have to keep in mind. Okay, so that needs to be done. So let's sort of do this. Okay, very very simplest of things. So only I generally will not ask anything related to this in the internals and all, because everyone can do. I don't want that. I want only challenging to be written things. Okay, so let's do what is Strassen's matrix multiplication, the fourth application of your divide and conquer technique. Okay, now what is the thing to be kept in mind based with regard to this? Very very long ago, we saw very things related to the time complexity of matrix multiplication. The time complexity of, I'm talking about matrix in general. Okay, the time complexity of matrix multiplication came up to be what? Equal to theta of n cube. Okay, theta of n cube, which is with regard to the traditional approach, we using divide and conquer technique. The matrix multiplication came up to as theta of n cube. Now, what is the thing? There is this person called Strassen, who found out a new method where the number of multiplications can be reduced. Okay, what is that new method? Or what is that new formula you found out? Who is this Strassen guy? Some mad guy. Okay, doesn't have any work, so he came up with what is known as figuring out what is a new way of doing or what is the easier way of doing matrix multiplication. So what did he do? What did he do? Okay, what did he do is he gave this formula. Okay, what is that formula? And this formula, be careful here. This formula works very, very good or only good for a 2 cross 2 matrices. What's the meaning of 2 cross 2 matrix? A should also be 2 cross 2 matrix. B should also be 2 cross 2 matrix. So that would mean A into B. How to write A into B? A into B, which is nothing equal to C, will also be what? 2 cross 2 matrix. So this guy, who is that? This guy, okay? This guy called Strassen came up with a formula to figure out how to or how to write a 2 cross 2 matrix. How to get a bigger or a better solution or a easier solution or a faster solution with regard to matrix multiplication, and he called it as Strassen's matrix multiplication. What is the disadvantage? It works only for 2 cross 2 matrix. What if it is more? You use conventional method. Okay. What if it's a 3 cross 4 or a 4 cross 3? You use conventional method. Okay. What if 2 cross 2? Go for Strassens. That's what he says. Okay. My method will work for only 2 cross 2. All other things you do on your own. That's what his problem is. Okay. For this, we need to study. Okay. We need to study and we are going to study. What is the way of doing it? Okay. So just listen to it. Okay. Very, very important aspect of it. Okay. Now, can I represent this entire? Okay. I'm going to represent 2 cross 2 matrix. I'm going to take first as A. So what are the elements that will be in A? I don't know what are the elements. So I'm going to take like this. Okay. What are the elements that are in A? A1, A2, A3, A4. Is it a 2 cross 2 matrix? Yes. Then I'm going to take B. Okay. So you know what is the thing I'll write. B1, B2, B3, B4. Okay. Then that will be equal to A into B or A cross B or A into multiplication B, which is nothing but equal to C. C is equal to A into B. And what will be this? This will be entire thing. It will be equal to what? C1, C2, C3, C3, and this is C4. But he told, okay, how can I write these values? Okay, how can I write these values, or how do the values can be written like this? For this, he gave a formula. This formula needs to be kept in mind. This formula needs to be biated, or remembered, or whatever you do, whatever you feel like doing. But it should be kept in mind. It should be remembered. What is this formula? This is where, I'm telling you, it becomes very important. Please remember this neatly, correctly. The formula that is going to come. You don't have to, worry how this formula came and all. Probably that Strassen guy will be knowing it. You don't have to worry. You need to write, or you need to know what is the formula. You can write this entire formula like this. M1 plus M4 minus M5 plus M7. Now, what is M and all? I'll tell. Okay. Now, people may be thinking, what is M? There is no M at all. Okay. I'm going to tell. Okay. Don't worry. Okay. Then I'm going to say M3 plus M5. Then M2 plus M4. Then M1 plus M3. Be careful here. Minus M2 plus M6. So there are lots of values. Now, how many ever times, even I start to buy it or sort of remember, I'll always forget. Okay. So I have to at least see once or twice, before we start doing a class and all. Because it's like, there's so many terms like this. There's no way to remember also. Okay. And we study only for a minimal amount of time. It's not like your A plus B whole square, where you start off studying way back in your school level, where you know what is A plus B whole square. Okay, A square plus B square plus 2AB. Okay, for people who don't know, go back to school. So what we are going to sort of look here. How you are going to remember this? See this, you got what is known as 1, then where is 2? 2 is not nowhere here. 3. Sorry, 2 here. Then 3 is right here. Then, okay, 4. Then 5. Then where is 6? 6 is somewhere here, but 4 will be coming here also. Okay, then 5, 6 over. Then 7, is there a 7? Yes. But there are other things also that will come. Okay, you see this, there is a minus M5 and there is a plus M5. Okay, and then there's a M1 here, there's a M1 here, there's a M3, where is somewhere M3? Yeah, here. So you got your M3 here, you got your M3 here. Okay, same thing with regard to M2. Okay, be careful with M2. Where do your M2 come? Is right here and also right here. And of course, M6. And what are the elements that are sort of not repeated? Okay, that is something that you need to think of. Okay, see, there's an M4 plus M4, and again there is a plus M4. So what are the elements that are not repeated? The elements that are not repeated are M7, M6. People may be buy, how do you buy it? It's up to you. You can take this as 1, 4, 5, 7. Okay, 3, 5, 2, 4, 1, 3, 2, 6. Okay, 1, 3, 2, 6. And you see this, and where do you think the minus values are? The minus values, wherever that is, you need to keep in mind. Where is that? The one that is there right here, the third element in the first thing, and the third element in the last one. So that you can sort of remember. I remember these numbers, based on that only I wrote this. Okay, 1, 4, minus 5, 7, 3, 5. Okay, 2, 4, 1, 3, minus 2, 6. But what is M1, M2, M2 and all, that we need to know, right? That we sort of to know, and that is where I'm going to write this. Okay, M1 will be equal to what? Be careful here. A1. Now this you can know right from here. Okay, A1 plus A4 into B1 plus B4. A1, A4. Okay, then M2 will be equal to A3 plus A4 into B1. Okay, then same thing with regard to M3. M3 will equal to A1 into B2 minus B4. M4 equal to, see again, I know people may be thinking, how to buy this. There's no other way. Okay, there's just no other way. Stupid video gives such things. You need to remember. I think people may be thinking it's more easier to do it in a conventional matrix multiplication. Okay, using all this instead of using all this. Yeah, but the problem here is the thinking that people need to keep in mind here is that this involves divide and conquer technique. So when they started using divide and conquer technique, they want you to put everything related to it. Okay, so only they have taken this. That's the only reason. Okay, then M6 and of course there is M7. M6 is A3 minus A1, then of course into B1 plus B2. Then again this is equal to A2 minus A4 into B3 plus B4. So maybe getting confused, I know, but can't help it. Such a big one, right? Such a big one. Okay, first of all, this you need to remember. After this you need to remember. How you remember, it's all up to you. Okay, it's all up to you. You need to somehow remember. But what is the advantage is in exam they generally ask you the direct value. Okay, they may generally go for a direct value, but again for that you need to remember what is known as the values to it. Okay, so the formulas to it. So can't help. Okay, can't help. So if they give this, it is very much clear from the above relation that Strassen's multiplication algorithm require what? 7 multiplications. Is that correct? Yeah, M7 multiplication 7 multiplications and 18 addition subtraction. If you count, you will get 18. Okay, 18 addition subtraction you need to have. Okay, where divide and conquer technique require what? 8 multiplication and 4 addition. So if you take 2 examples, I'm going to take 2 examples. Okay, and I'm going to figure out what needs to be done with regard to it. Okay, what is the example we can take? We can take the same example, whatever that is there in your textbook with regard to A and B. Okay, what is A? I'm going to take again 2 cross 2 matrix. Again B, I'm going to take it as 2 cross 2 matrix. If I do that, what is the value that I'm supposed to get? Okay, so if I take that, okay, if I sort of write it here itself, that's one more color. Okay, so A value, if the A value is like this 1, 2, 5, 6, and the B value is very much like this 8, 7, 1, 2. A value and B value. This is the values I have taken. Okay. So for all for all of this, if I start writing the values for it based on this one, this is nothing but A1, A2. This is A3, A4. Then again, this one is B1, B2, B3, B4. So can I write the values for this easily? Yes, I can always do it. Okay. So what do you think the first one value will be? The first value will be A1 plus A4. So A1 plus A4, 1 plus 6. Okay. Into 6 plus 4. Okay. Which is nothing but you can see B1 plus B4. So B1 is 8. Okay. Not 6. So B1 plus B4. Okay. Like this. If I write this. Okay. If I start writing this, what is the values I'm supposed to get? Okay, what is the values I'm supposed to get, or what is the values I'll get is, very simple way. Okay, this values will be very much equal to when you put all these values towards this side. Okay, so what is the values that you're going to get? You get the values with regard to, take those values. Okay, you figure out what is the value. First one. Okay, 1 A1 plus A4. So 1 plus 6, the first one. Then into B1 plus B4. B1 being your 8 plus B4 being what is known as 2. Okay, 8 plus 2. That when you put all those values right here, you get all these values, right? M1, M2, M3, M4, M5, M6, M7. Okay, then what you get is with regard to C will be equal to, you put all those values right here. Okay, you will be going to put all these values right here. Then you are going to get a matrix for it. Then when you do simplification, you are going to get at last as 12, 13, 48 and 49. Okay, this is what you're going to get. And then based on that, we are going to figure out how it is divide and conquer technique, all those things. Okay, and we are going to figure out what is the time complexity of it also. This is only the tracing part of it. The tracing part, again, I told you, okay, it's pretty